Hi everyone, and welcome to today's lesson where we're going to go over graphing systems of equations. So first off, let's talk about what a system of equation even is. A system of equations is when you have two or more equations and you're trying to find where they intersect. All right, for right now and for all of our class, we're going to be dealing with simply two equations, but you are trying to find, so the solutions is where the graphs intersect. Okay? And to that end, there are three possible answers. They can either have one solution, which is where they intersect in one singular place. They can have infinitely many solutions, which is when the lines overlap. Or they can have no solutions, which is where the lines never touch at all. Now, as we describe these, we're going to have a few other words to it. If there's exactly one solution, this is going to be a consistent and independent graph. Okay, so consistent means that it has at least one solution. All right, so both exactly one and infinitely many are consistent graphs because they have at least one solution. Independent means there is only one solution. So consistent means there is a solution, independent, only one, which is why dependent is used for the infinitely many, because that means that there are more than one solution. So if consistent means there is a solution, then inconsistent is the word we use whenever we want to describe something that doesn't have a solution. And if it doesn't have a solution, that means these lines are parallel. So make sure you keep that in mind. All right, now let's practice using these vocab words. You're going to want to make sure you know these vocab words. They will come back either on a test or a quiz. So let's start with A first. So negative 2x plus 3. So as a reminder of how to read a graph, you first look for the y-intercept. So positive 3 is this point right here. Negative 2x is our slope. So we're going to go down 2 over 1, and that ends up being the green graph. Okay, so I'm going to put a little g. Next, we've got y is equal to 5, or x minus 5. Minus 5 is our y-intercept, so coming down here. And then x is a positive slope, so it means we have our purple graph. Now we want to determine whether or not these are consistent or inconsistent, and if it's consistent, whether it's independent or dependent. So I'm looking for whether or not the purple and the green graph intersect, and yes, they do. They intersect right here. So it's going to be consistent. And since it's only one spot, it's going to be independent as well. So consistent and independent. Now, with some of these graphs, it's really easy to tell whether or not you at least have a consistent graph. Because remember, if it's inconsistent, that means the lines are parallel. So one thing you can do is you can look at the slope. All right, the slope in this case was a negative 2. In this case, it was a 1. That isn't the same slope, so there's no way these graphs are parallel. So you know at the very least they're going to be consistent. Independent or dependent, you still got to figure that out. But you know from the offset, consistent or inconsistent. Now take B, for example. This one is negative 2. This one is 2. So at the very least, I know that this is going to be a consistent graph. Or a consistent systems, I should say. Now let's look over at our graph. All right, now negative 2x minus 5, that's going to be this red graph, so or this red line, so I'm going to say red. All right, and then 2x plus 3 is the blue graph. So I'm looking for where the red and the blue graph intersect, and that's right there. So this is going to be an independent. turn. Do C. When the video plays again, you'll see the right answer. How'd you do? So the green and the red line are both parallel lines, and you can tell because they have the same slope. The green line has a slope of -2, and so does the red line. So these lines are going to be inconsistent because they do not have a solution. Now last but not least, go ahead and try D. Now you may on this one have to move things around and get it set up in slope-intercept form, but go ahead, see if you can figure it out. So when the video plays again, you'll see the right answer. And here you go. So for that first equation, when you got y by itself, okay, you divided 2 to the whole equation, and that got you y is equal to 2x plus 3. This is the exact same equation as the second equation, which means that these are two lines that overlap, okay? Yes, they're the exact same line, and so you have two individual lines that are overlapping each other, which is why it is a consistent dependent graph. All right, now that we've gotten pretty good at reading the graphs and understanding them, let's go ahead and actually do the graphing. So first up, we're going to go through each of our patterns. We're going to talk about graphs that have one solution. Then we're going to talk about graphs that have no solution or infinitely many. And then we'll just do a random assortment. Okay, so we got a couple of rounds of graphing. Please make sure you have these in your notes. You need to know how to graph from this section. If you're still shaky on how to graph, there should be a video posted on my SJ for that. All right, here we go. Now, when we are solving by graphing, we're going to graph the first equation, then the next equation, and see where they intersect. So, here we go. First one, I'm going to do it in blue so you can see it. That is -3x plus 10. So my y-intercept is positive 10. Sorry, it's a -3x plus 10. Now my slope is -3x. I'm going to count down 1, 2, 3 over 1. I'm going to do 3 dots. 1, 2, 3. You don't need 3 dots, but 3 dots are helpful, especially here. I'm actually going to do a few more than 3 dots. Now the reason why I'm being very careful is because the solution to this is where the lines intersect. And if you don't have a straight line, then you're not going to see your intersection. Oh, wrong button. All right, it's about as straight as I can get it. You would want either a ruler or a straight edge or just a lot of points. That way you can guarantee you have all the points of intersection. Now next, I'm going to do the other one, which is x minus 2. So I'm going to go down here to -2, -2, up 1 over 1, up 1 over 1, and this actually intersects in a nice, neat point. There we go. Now our solution is where it intersects. So it is this shared point in the middle. And that shared point right there is going to be 3, 1. This is our answer. A couple things I want you to know about my answer. It is a point, okay, which means it has to have the parentheses, comma in the middle. All right, it is an XY coordinates. Make sure you have it as a point. Okay, let's keep going. Now, on this one, as I mentioned earlier, we're going to play around with our other solutions. But what I want you to do, go ahead and try to graph these on your own first and get a little more practice with graphing. When the video plays again, I'm going to go over all the steps. So good luck. All right, so here we go. I'm going to go through this pretty quickly. I'm going to use red for my first one, blue for my second. And I'm going to put down multiple points because on the iPad it's hard to draw a straight line. And with multiple points, I can guarantee the intersection. So my red one first, that is 1/2 x minus 2. So here's -2. Now it's a positive slope, so this is going to go up. So I'm going to go up 1 over 2, up 1 over 2, And then go back the other way, down 1 over 2. That should give me my point. Please notice how when I draw my line, I have an actual line complete with 2 arrows. Please make sure that when you do your graphs, all right, your graphs have arrows as well. So this is going to be a positive 2 as my y-intercept, and same slope. So I'm going to go up 1 over 2, up 1 over 2, and down 1 over 2. And there it is. Now, these two graphs are parallel, so there is going to be no solution on this one. Okay? You could have told that simply by looking at the equations, but they wanted us to solve by graphing, so consider it good practice with graphing. Also, it's nice to know what these look like, because when we start solving equations, we're not always going to have the picture in front of us. So being able to draw the picture and read the equation are both completely valid and important skills. All right, go ahead and try number 2. And here I go. So red on top, blue on the bottom. So red, this is going to be a negative, or y is equal to negative 4/3 x minus 3. So I already know this is going to be a negative graph. But if I go down any further, I'm going to go off the graph, which isn't a problem. Okay, you can always expand your graph, but I'm going to go the other direction. So I'm going to go up 4 to the left 3. So up 1, 2, 3, 4 to the left 1, 2, 3. All right, one more time. Up 1, 2, 3, 4 to the left 1, 2. I am going to expand my graph and do a third point over here. I don't think the graphs are going to intersect all the way out there, but it's nice to have a third point. Now notice how even though I went backwards, okay, I went up and to the left, I still have a negative slope. The beauty of the slope is you can go left or right, and if you do the slope correctly, you get the same exact answer. Now let's do the blue graph. Okay, this is going to be x plus 4. So 4 is over here, and this is a positive slope. But if I go up any further, I'm going off the graph. So I'm going to go down 1 and to the left 1. Down 1, left 1, down 1, left 1. And you can see that my graph, it has still a positive slope. So I did it right. And in this case, we have a solution. The point of intersection is going to be negative 3, comma 1. And there are the answers. All right, one more round, and then we will do a special case. So go ahead, the video is going to pause. When it plays again, you'll see the answers for both of these. Make sure that your graphs match mine and that you have written your solution properly. Go for it. And here are the answers to both graphs, to both systems of equations, I should say. Now again, I made multiple points to guarantee that my graphs would intersect. If you don't want to do multiple points, you can use a straight edge. Just make sure that you are very, very straight. Because what you don't want to happen is you don't want to be off slightly and your graph miss a point it was supposed to go through. So I highly recommend you just draw multiple points and then use a straight edge to connect them all. Alrighty, last but not least, what about if the equations are not set up nicely? So up until this point, all of our equations have been set up in slope-intercept form, which is a fabulous way to graph. But what happens if they're not? Well, you have to rewrite them in slope-intercept form. Okay, so here's my red graph, and here's my blue graph. So my red graph is going to be 2x minus y is equal to negative 1. I need to get y by itself, so I'm going to start moving pieces to the other side. And hopefully as I do it, this is becoming more and more familiar to you. So multiply the entire equation by negative 1 to change all of my signs. And there's my red graph. I'm going to go ahead and graph it while I'm in the right color. So positive 1, up 2 over 1, up 2 over 1, and once in the other direction. There we go. Alright, and now let's move on to the blue graph. So 4x minus 2y is equal to 6. Subtract 4x from both sides. Make sure when you're doing this, you take your signs with you. Never want to forget your signs. Divide the whole equation by a -2. It's going to cancel out that. We have y is equal to 2x plus, that is a 3. That's a -3. So I need to change my sign. Because a +6 divided by a -2 is a -3. So start off at -3, and we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And if you weren't aware from the equation, you should be aware now that these lines are parallel, and therefore there is no solution, because these graphs are inconsistent. Alright, and that is the entire lesson. Please let me know if you have any questions, and I will see you next time.